from the parent function, but from other equations. So given a full equation, move it around, just like we practiced moving the parent function around yesterday. But it goes right from these models, so it's not too far of a jump. Your challenge was to write a quadratic function. So I would start here. I would start by writing this. If you were stuck, had no idea what to do, write down this model exactly like it looks. This is the quadratic model. Start with that. Okay. And I want a quadratic function that shows a vertical shrink of 1/2. So where should I put 1/2 into this equation to make a shrink? The A, the H, or the K? Yes, in the A. Good job. So I'm going to take the A out, and I'll put 1/2 in, because that's where a shrink belongs. This is going to multiply everything by 1/2, making it half as tall. All right, we need, oh, I meant to fix this typo. There's a typo here. Like something in the font. This is supposed to be -5. Did you guys see this? Sorry. We're going to, raise your hand if you did it as a -5. Raise your hand if you did a +5. Sorry, it's meant to be a -5. It just got separated. Nice. Okay. So a horizontal translation of -5. Where should I put -5? In the H spot or the K spot? H. There it is. Put my -5 in. Yeah. Yes, let's turn that into a positive. We don't write minus and negative. We're going to turn that into a positive. Oh, yeah, if you guys. Oh, I don't know. All right. And our last value would be K. Vertical translations go in the K spot. So I'll take the K out and I'll put the 3 in. Okay. So this is the parent quadratic function. It's a parabola. It's half as tall. I can picture it left 5 and I can picture it up 3. Can you picture it? No? You will eventually. You know. All right, I'm actually going to I'm going to add to this. I'm going to do a problem I haven't asked you to do yet. I haven't asked you that for you. But I'm going to do one that has to do with our goal here. So I'm going to change this from Y and I'm going to call it F. You do it too. If you put Y, go ahead and make it F. Call your function F. His name is Frank. Frank. All right, so this is our new challenge. I want you to translate f of x down 5 units. Call your new function g of x. So what's new about this is I'm not changing the parent function. I'm changing this one. Take this one down 5. And I'm going to write a note for you since I haven't even told you how to do this. I want you to guess, try something. You may just figure it out on your own.
So like we had 20 minutes left in period, so and there was already a class test. So like a quarter of our class got it done.
Hold on. Just to compare. I just want to grab. Hold on. Just give me a sec. Let me just grab one more drink. Hold on. Okay. They move so well. They will make you look pale. I recommend you take a Sharpie because it will. You'll make you look. Have this 5.
The necklace on this one.
Hey, the necklace is fine. Don't disrespect.
And school photo.
All right, go ahead and write down the note I did just so that you have it.
It could be worse.
Did you write that
I went from.
All right, so if we want to change this and make it an up-down movement, we're going to outer subtract from k. So my new function g of x I'm going to put a minus 5 at the end, and that's going to move it down. You don't want to show your work? No, go ahead and show your work for now, okay? And that's g of x. Okay, so I wouldn't be surprised if a lot of you, this is what I would have done. I would have just erased the minus 3 and put a minus 5 in. Because that's kind of what we were doing with the parent function. We were just plugging whatever the move was in. But since we're translating, it's already up 3. We're going to take it down 5. We do 3 minus 5, and we end up at minus 2. Okay? That's our new move today. Given an equation, change that given equation. All right, get out your assignment from yesterday. Compare your graphs with the people's in your group. You have a question about this bell work or about homework? Okay.
I knew it. No, I don't need a question. Wait, but I actually do have a question. I need to take a selfie.
As part of our assignment in all class, we did take pictures with like not like every picture. We get to choose like every like it's like kind of like a bingo board. You could get a bingo. So
I think I remember. I got one that
like pictures.
I might get a bunch of questions.
Already has a subtraction sign.
I don't want to know what it calls.
If I'm moving it left and I put a negative in there,
No, I like because
It's not really more. As you go through the year with tables and graphing, it'll start to make sense. I can do a table just so if I
It's just she's I might even I couldn't
Well, I feel like that's usually what you're gonna tell you.
I know.
I just couldn't think it's okay. Like, if you're a good person,
I don't
there's always something
get
going wrong. Something with the boy, or it's exhausting. I told her this before, and then she said that I'm not supporting her. I'm like, you know what?
I got that too. I said it's like this.
All right, I heard some really productive questions. Does anybody have a question that I did not get to? I see a lot of people correcting things. That's what I want to see. I don't want 100% right homework. Yes. So you guys, you see how I have, it says to graph the parent function and the function. I put all my parent functions in green. Please put both. So as I walk around, I want to see 2 lines on every problem. Okay.
It's just kind of like in general. I don't know. Like I kind of get it, but at the same time I kind of don't. Like I get the parent function, but it's just kind of like the whole graphing thing. Like if I looked at it and you said which one is like that, I know that's quadratic. Like I know that one's absolute, but it's just like I don't know. And like I know like that part, but I just don't know like how to like, graph them and then contrast them and then the stretch and.
Yes, we haven't really done much with stretching at all. But what I can say is it's still a work in progress. We're still working on it today. It's all the same topics up until next Tuesday. So just stick with it.
Okay.
We're adding to it. It's kind of slow.
Okay. Thank you.
All right. So I do want to say you might kind of be feeling like, why are we doing this? What is the purpose? So I want to remind you that a lot of these functions are really applied to like modern day engineering and math. Parabolas are actually everywhere in architecture. They show up in nature, like biologists and scientists model the way a dolphin jumps from a parabola. They use a parabolic function. That's the shape that they make. And then there's actually a good example I always like to bring up. Raise your hand if you've seen the movie Hidden Figures. Oh, I've seen it. Okay, so in the movie, and when the movie came out, I actually had people go see it for extra credit. In the movie, they have to turn an elliptical orbit into a parabolic orbit. Like, so the way NASA was modeling, so the mathematician, the movie is about like the female mathematicians that were in the background that weren't really getting all of the same opportunities and treatment as like the white male NASA engineers. But what the story actually is here's Earth, and they took a shuttle to the moon, and as the shuttle was coming back, the equation they were using, as it returned to Earth, they were using an elliptical equation, and once the shuttle entered the atmosphere and was a part of the gravitational pull, it was on this elliptical path. And the scientists figured out that it was going to make them crash. Like the astronauts weren't going to make it, and neither was the really expensive equipment. So they figured out that a parabolic path is what would work. So they were trying to figure out, instead of this, how to get the space shuttle to do this. And that was going to help the space shuttle help them separate and land safely. And the engineers, they just couldn't figure it out. And then her name was Katherine Johnson. She did a formula called Euler's formula. That's a part of ACE math. It's in calculus. It's in like advanced high school math. And she was able to change the formula from an ellipse to a parabola. And they made it home safe. So a lot of it's software, right? So engineers, architects, you can even think of like a conveyor belt, like the way like a candy bar falls off of a conveyor belt onto something below it. That's actually half of a parabola. So like the software that designs that is using like an x squared formula. So if it's not landing where they want it to, let's say this is what like, let's put like time here. Let's say this is what NASA was doing, right? Completely made this up. But if it's not landing, they're going to make the parabola wider. They're going to alter these numbers. They're going to, with their mouse, change the model and what it looks like. And it's changing the numbers on this equation. If it's a different time of year and there's a different place in the orbits or whatever, maybe they change the H or maybe they change the K. But it's all very applicable. Okay? So I have a little challenge for you. I want you to really see why transformations can be useful. So we're going to go to your notes now. Save that negative fraction. So we're starting on the second section of chapter 1. So introducing you to that model was section 1. Now we're focusing on linear and absolute value functions specifically. So if you want to put this title on your notes, we're now moved to 1.2. And your quiz in 1 week includes 1.3. So you have a 3-section quiz in 1 week, all about transformations. And every day it's just, we're just adding more and more to it. Okay. And you don't have to write all that out. I just want you to know where it is in the book. I have this section of the book posted in Schoology for you right now, so you can look at it since you don't have your own books yet. Right. Here's your challenge. I want you guys to do this in your groups. You're gonna graph this equation in 2 ways. Hi. Well, no, because every website's working. My textbook site didn't just work, but. All right, we're gonna graph this equation in 2 ways. Our first way is to use a table. Our second way, same equation, is to use the transformation method. So I'm going to give you guys some time to fill out this table and plot the points. I'll show you what I mean. You're replacing x with these values and you're getting an ordered pair. You plot those points. See what I did? You're going to take these, plug them in, do a little quick math, get a point, plot a point. And even if you can like already predict the point of the assignment, do it anyway.
But the reason it's positive is because it's 1 minus 4. 1 minus 4. Negative 3. Negative 3.
I'm good for it. It's all yours.
There's actually negative 5.
I didn't bring like 5.
No.
Why is it not?
Because it's in the absolute value.
I was still behind. I was still right there. I'm class with 3 A's and a B in class only. And then I passed the thing. So I'm
Oh, it was weird though, because I would ask them, like, hey, does this look right? And they're like, yeah.
All right, so here's the math. Here's the table. And this looks Okay, it's supposed to be a V shape, and we have a linear graph. What's going on here, Adrian?
Instead of the 3, it should be 5. It's 1, 3.
No, that's okay. 1 minus 4. You got a 5? It's right. Thanks for asking that. Sometimes it's not. You're saying this number should be a 5? Right? Is that what you're saying? It's okay. Look at it. 1 take away 4, negative 3. Okay. Who else has a question? Yeah. What do you have? What do you have to say?
Well, like, it looks like a linear graph for now because it hasn't reached its lowest point.
It hasn't reached the vertex, the lowest point. We can't see the V shape. So you can't just throw together any table for any function and think it's going to be a good graph. So if we want to use this method, we have to keep going. Like this is not an absolute value graph. So we're going to keep our table going until we see a vertex, until we see a point. Keep it going. Let's split it up. All you guys plug positive 3 in. All you guys just do the positive 4, and all you guys just do the positive 5. And then we can just copy each other. So some of you guys have asked me, like, why if it's subtraction does it move right? Right? You guys have asked me that. Why would a minus sign move something right? And maybe plugging in is going to help you. Like when I put a positive 4 in here, I end up with the y value 0, and I'm right 4. Like, so when I get to x equals 4 is here. 4 minus 4 is 0, and I'm at the y-axis, and I'm over this way. I'm not over this way. Left would be I was putting a negative 4 in there, and that would lead me to 0, and it doesn't. It's over here at positive 4 that I end up with 0. So I can see when the y value goes from 1 to 0, and then back up to 1, I know I found my bottom point, because it went down and then turned back up. Okay, and then from the reflexive property, we could just mirror these points over. But you do have to extend your table all the way until you find the vertex. Okay, now we can do letter B and just use our transformations. What is the minus 4 there? Bailey, this minus 4 in the equation, does it represent A, an H, or a K value? Yeah. It's an H. It's in the bars. It's an H. So an H shows a horizontal translation opposite. So to use the transformation method, all we have to do is move the parent function horizontally 4. So I could use, this is the parent. I'm going to transfer that right 4 units. And there it is. So guys, which way's better? The table method or understanding transformations? Understanding transformations, man, that was so quick and efficient. I'm not saying it doesn't get more complicated than that. It does. Like even with transformations, at times we will use a table to get it right. But really understanding how the numbers in the equation are going to move that graph around is so much more efficient than relying on tables to graph forever. So let's make a nice statement and give credit where credit is due. We need to thank all of the mathematicians before us who figured this out. Because we don't have to rely on the tables. Somebody figured it out. You put a number right in those brackets and that just moves it right left. Okay. Thank you, mathematicians of the past. We don't have to do that way. All right, now we're going to move on. And it's gone. Okay. This is a kind of a fancy formal model from the notes I gave you yesterday. Yesterday I told you horizontal translations is called H, and it shows up in parentheses or brackets with K. Here you can see the arrows moving right, left. And here a vertical translation shows up at the end, and it moves something up or down. So that's the formal model. Pretty cool. Something to look at if you want to understand this a little more deeply. Okay, so here's our function f of x. We're going to change it in two ways. First, we're going to write a function called g. We're going to name it g. And we want to go 3 units down from f. So this is what I told you to do in Bellwert. For vertical translations, add or subtract from k. Go ahead and do it. Go ahead and do this example. If you didn't write this down, write it down so that you remember what you're doing when you're asked to do that. This is like number 3 from Bellwert. All right, so up or down, I just put that number in the end. Up or down means I changed k. And my directions say to call my new function g. Here's my answer. G of x is not a transformation from the parent anymore. G of x is a transformation from f of x here. So it's that same equation down to. Letter B says, take f of x and move it to the left. For horizontal translations, we want to add or subtract from the x value, not from the k value. Switch over the word opposite here. So I'm going to do 2. So I want to go 2 to the left. I'm dying to write -2, but for horizontal translations, we do the opposite. So this +2 that I've inserted with parentheses is going to shift my linear equation left 2. And we're going to finish it. We're going to distribute in and finish it before we name it 8. Now that's pretty unpredictable. I would have called that up 4 from F. But up 4 and 2 left looks the same. This looks like up 4, but it, graphing up 4 and 2 left for that actually looks the same. Questions? Or one more? One more idea. 2 more problems. What am I going to put? Our reflections. Sort this on the board. To reflect across the x-axis, you multiply the entire equation by -1. I haven't said anything yet about reflecting across y. So you can reflect horizontally this way. To reflect across y, you only multiply the x value by -1. To reflect across the y-axis, multiply only the x value by -1. And I posted the textbook in Schoology, so if you're feeling like, man, this makes no sense, a great place to look is to read the words in the book, you know, in a quiet place. Look at the example, read the words, see what the textbook authors say about it. All right, last problem. Our function is the absolute value of x plus 3 plus 1. Our challenge is to reflect it across x and then rename it g. So to reflect across an x-axis, we take the entire equation and multiply it by -1. I'm going to use parentheses. And now I'm going to write this here. And we're going to need to think back and rely on some algebra skills. You do not distribute into absolute value bars. That's a common mistake. Is to multiply into absolute. You cannot break into those bars. So when I distribute in, I'll end up with a negative here in the front, and I'm going to go all the way across to that plus line. And there it is. If you guys are familiar with Desmos.com, like Desmos will graph that for you, and then you can put in what you did and see like if it looks like a reflection. So F looks like this. It's opening up. It's left 3 and up 1. I can see H and K. I multiplied everything by -1. It's the same equation, but it's going to be flipped across X. You don't have to write down the next one. I'm going to do it. The answer to the next one would be the negative sign would be right in front of the X to reflect across Y. All right. So your assignment is to try this 13 times. It's page 17, 1 through 13. I've posted the problems in Schoology. So everybody started their syllabus. You had access to Schoology. So is anybody not able to get into their Schoology account? Okay. So go to Schoology for that.